Good afternoon, ladies and gentlemen, here in Silicon Valley, 11th Cloud Expo. Here we are, day 2. We've reached the early afternoon, I want to say. I have to check my own watch now. Not even midday. Next up, challenges and opportunities. Challenges and opportunities. I always like that when it goes together with cloud. Gary Ballabio, Product Line Director of Akamai, has 30 minutes to explain this and his cloud-based application delivery strategy. Come on, Gary, that's a lot to get through, I'm sure.
Absolutely, thank you very much. All right, so I've been coming to these different cloud events, the SYS-CON conferences for the past few years, and essentially Akamai sponsors our booth, and I sit in the booth, and one of the questions that I'm commonly asked in the booth is people walk up and they go, Akamai, what are you guys doing here? And it's one of my favorite questions to actually get, because I love educating people on how Akamai fits into cloud strategies and how Akamai can really enable cloud adoption. Essentially, Akamai has many capabilities. We're going to go through them today that really align very well to cloud services, running applications from the cloud, or adopting SaaS infrastructures. And what's very interesting is that if you look at the challenges that you face with running an application from the cloud, it's very similar to the challenges that you face with just straight up hosting the application yourself and serving the application from a centralized environment or even a distributed environment, a traditional hosting model. And the other part is that Akamai has a very unique capability in solving specific challenges when the application is no longer in your control. So your company is adopting a SaaS platform and users are complaining about performance or having performance challenges on a global basis. We actually have an offering that you can leverage to actually address such challenges, and we'll go over that today. So from a high level, because we only have 30 minutes, we're going to go through 3 main areas. So one, we're going to talk about how Akamai just addresses performance and optimizes scale globally. We're going to talk about updates that we provided to our platform to essentially address flexibility and help you attain that promise of the cloud of agility and flexibility. And we'll also talk about some of the challenges that arise with security. Of course, as you move an application off of your platform into another environment, you lose control and security becomes an utmost concern. And we'll talk through how Akamai can actually help with that as well. But from a high level, for those of you who are not familiar with Akamai at all, I want to take a step back and just give you an overview of who Akamai is. So Akamai runs distributed platform of servers, upwards of about 110,000 servers or so. And a lot of people don't realize, but we run anywhere from 15 to 30% of the world's internet traffic, all flowing through our platform. And our platform is vast, so we have a great number of servers. But we strategically place our servers in parts of the world where end users are. And that's really core of our platform and our technology. You can see a statistic here. 90% of the world's internet end users are within one network hop or one AS hop of an Akamai server. So it's not just a shotgun approach where we just throw servers out there anywhere in the world. We strategically place them within ISPs that are the most popular ISPs around the globe, as well as the backbone providers. So we're in both locations, and that allows us to provide improvements for end users, as well as improvements in the middle mile, and we'll get into the details of that today. The service itself is transparent to end users, so it's based on a DNS implementation. So you essentially take a host name and you point it over to Akamai, and from there we apply capabilities that improve performance, improve the scale, and also the security. So with that, I'll turn over to the performance and scale and talk a little bit more of how we enable that improved performance. So from a high level, a lot of you are IT professionals. You understand a lot about the internet, but from an average consumer or an average end user, they open up a web browser, they type in a URL, and they just expect it to show up. It seems very simple to them, right? But for a lot of you, you understand that the internet itself is actually more complicated than that. It's made up of 12,000 different networks, all of which have to work well together in order to achieve that promise that that average end user is assuming. That when they pop in a URL into a browser, the content just magically appears. And of course, there are challenges with that. Now, cloud data centers, they're built on, for the most part, on backbone providers, and they have to connect to the internet like anybody else connects to the internet who's, hosting, some sort of content. The problems come in the middle mile, right, operating on the internet. The internet is built on a protocol, so BGP, so it stands for Border Gateway Protocol. And that protocol is not a performance-based protocol. It's really based on, more of the economics of the network providers and does not always result in the best, most optimal route for your end user to go and retrieve that content, which is hosted on the cloud provider. Now, the other problem is really just around availability. So there are times where problems happen on the internet. Maybe connectivity to a cloud center goes down, right? And that it decreases the availability for some of your end users. And there's also times where just the middle mile has problems. So there may be no problems with the actual cloud provider itself, its connectivity. There may be no problems with the end user's connectivity, but they still can't reach where your application is hosted. And that comes down to peering problems or just issues in the middle mile. All of these are pretty much outside of your control. But what Akamai does is our unique approach is we distribute our servers across the internet to work around such problems. So with our servers, we're able to serve the content more locally to end users. So we can essentially bypass problems that are happening in the middle mile or that are happening in the middle of the internet. We can also ensure that in cases of failures where you cannot reach a certain cloud provider, we can serve content from our servers directly, or we can even provide sophisticated failover rules to move from one location of an origin to another. Now, the other thing that we can do is in terms of the middle mile. We're able to actually leverage our wide breadth of servers to figure out alternative routes through the internet to retrieve the content. And you can think about this as a highway system, right? So Akamai's platform is built on the public internet, right? And you can think about it as, in your own local city. A lot of times there's many different ways to move from point A to point B. A lot of times, Google Maps will provide you some sort of default route that everybody takes. But as a local that there's a different road, there's a side road or somewhere else that you can take that's going to get you to your end location faster. And that's what Akamai does only on the internet. So let me talk about that routing capability in a little bit more detail. So from a high level, one of the challenges with delivering applications from the cloud just comes down to sheer location. You all know that if your end users were accessing applications locally, so within the same LAN, right, that performance is going to be the best that it can possibly be. The problem is that the cloud providers are not built, at the same LAN. They're not even built as close as that, right, to the end user. They're built on backbones, right? And so the further away you get, latency comes into play. You have those bottlenecks that happen in the middle mile. All these are now problems that you run into on the internet. So this comes back to our routing capabilities. So here we have our what we call our SureRoute technology. And it's a route optimization technology. What we're able to do is essentially leveraging our servers, provide alternative paths through the public internet. Right? Our servers are built on about 1,000 different networks, right? So it's much easier for us to find alternative paths that are not the default internet paths that everybody is using. And even in the case where one of our paths is down, we can fail over to other paths through our servers to ensure that the content reaches that end user successfully. And that's a feature that we call SureRoute. And just in terms of an example of our technology in the works, you can see here data from the Middle East cable cut, where we were running some data from some agents in India accessing an origin in the US. And you can see the cable cut actually happened in the beginning around the end of January. And you could see that the packet loss was trending, okay, but then when the cable cut happened, you see a dramatic shift in the actual packet loss that was measured in this test. On the Akamai side, because of the routing optimizations that we provide, we didn't see such an effect. And that's again because we're able to find these alternative paths, these alternative routes on the internet. And this is an extreme example, but it's a very clear example of what our technology is able to do. So the next is around optimizations at the connection. So the internet, one of the core parts of the internet is based on TCP. Right? TCP is a protocol that was designed in the 70s, and it's a very conservative protocol, but it also was not designed thinking about the high bandwidth connections that are actually in place today. And so what you find is that TCP itself is not really designed to optimize the connections that a lot of end users have today. And what we're able to do to overcome that, again, with our distributed set of servers, right, is to ensure that, number one, the connection is established as quickly as possible because we're distributing our servers. The end users are now connecting to a more local server, so the connection is established faster. And then once the connection is established, we'll move more data through those connections than standard or default TCP would. So that allows us to push more content through, reduce the number of round trips, and then ensure a faster response time for the loading of that web page. So the third one is around a feature that we call prefetching. As a lot of you are aware, you have your HTML page, which the browser ingests, and it parses through it to figure out what are the embedded objects it needs to go and fetch next. The problem with that is that they'll fetch objects maybe 2 to 4 at a time, and sometimes you'll see the web page loading gradually, right? And that could be a problem in just the sheer response time of the page. When you put Akamai in the middle of that, what we can actually do is serve the HTML page, but as we're serving it down to the end user, we can parse it. Right, even before the end user receives the HTML page, and pull in all those embedded objects and then serve it to the end user once the browser has caught up and actually starts requesting those embedded objects. So it allows us to more quickly ensure a loading of the page. The other thing that we can do here, and this is a newer offering of ours, is allow us to go and fetch this subsequent page that you think the end user is going to request next. And this is a capability that can help overcome back-end response time challenges or back-end challenges where it takes a longer time to generate the page. Using an HTML5 standard, we can parse the HTML page, look for specific parameters in the HTML, and actually call that next page based on your information or your knowledge of the end user's flow through the application. So in situations where the end user may go to page 2 next, we can go and fetch that, have it in memory, and create a browser ID for it to ensure that we only serve that page once and once only to that end user. So that can work for cacheable content as well as dynamic content. So just in terms of some data that we provide, so this is a test that we run for an application running on Amazon EC2. And you can see here it's hosted in North America, and you can see the response time that was achieved in North America. So an 8-second response time in North America. But as you move further and further away from where it's hosted, obviously the response times change. The response times are even more dramatically poor in the Asia-Pacific area, really because of the routing challenges that are there. It's nothing to do really with what Amazon is delivering. It comes down to the problems on the internet. With the capabilities that I just walked through, leveraging those, we're able to reduce the response times across the board. So you see here we reduced the response time in Europe in half, in Asia-Pac very dramatically, in Australia as well. But it comes down to the capabilities, and it comes down to being able to deliver the content more locally. So now we'll talk about flexibility and some of the new capabilities that we've put into place this year to address this. So the promise of the cloud is that you can be more agile. There's also cost considerations in there. But because of virtualization and because of the features a lot of these cloud providers provide, you're able to create applications quickly. You're able to create applications on their environment. And because of virtualization, it makes it very easy to port ththose applications from the public environment down to the private environment. And at Akamai, what we wanted to do was to give our customers who are creating these applications at that pace just as fast access, to the features that Akamai provides. So we created a feature that we call Instant Config, which allows you to put in place a template configuration on the Akamai platform, and then point any new application, to Akamai to receive instant benefits of Akamai. And as you move from one location to another, the same features can apply. And this is where a new technique that we have called edge load balancing can come into place. So this is in situations where you may be hosting in a private cloud as well as leveraging a public cloud, or you may be leveraging even multiple public cloud providers, and you want to ensure constant uptime or constant availability. What we're able to do is, because we're sitting in the middle and because we provide such high availability, in the event that one location is down, we can automatically fail over to a secondary location, right, in a primary, secondary type of an environment. We can also ensure that we can balance load across, multiple locations as well. And the event where maybe you're seeing, high load and you're starting to cloud burst or whatever, we can even react to that and ensure that we can pull content down from the various locations where the application may exist. That's a new technique that we developed this year that we call edge load balancing. Thirdly is around devices, right? So mobile is a very hot topic, but a lot of the capabilities that we provide and a lot of the capabilities that I walk through also apply to end users who are accessing your applications from mobile devices. But what we can also do is detect the type of mobile device that they are accessing that content from, and essentially redirect them to more appropriate content based on that device that they're requesting this from. Lastly is around connectivity. So IPv6 is becoming more and more rampant, and it will become more rampant over time. And what we can do is essentially, because Akamai is sitting in the middle between your end user and your infrastructure, even if the end user is coming in on an IPv6 connection, we can translate that to an IPv4 connection, so you don't have to upgrade your infrastructure as quickly as your end users are upgrading to IPv6. So again, providing you the agility, right, to meet the demands your end users face. So lastly, I'll talk about security. So Akamai provides a very natural defense mechanism just because we're a distributed platform, right? So when it comes to denial of service attacks, we naturally provide a defense mechanism to that. The problem that we're seeing is that nowadays we're seeing more and more denial of service attacks happen. Just in this data here that we're showing, you could see from 2011 to 2010 the dramatic increase in the number of attacks that we've been seeing. The attack sizes are also ranging as well. The typical or the average attack size that we see on our platform is anywhere from 3 to 10 gigabits per second. Now that's an attack on a specific site directly. And the attack sizes, are even ranging even higher, where some of the largest ones that we're seeing are up to 100 or 200 gigabits per second against a single site. And it's very hard to build out infrastructure to essentially handle this type of unexpected load, which is one of the advantages of using our platform. Now, not only are the denial of service attacks increasing, but also the types of attacks that we're seeing as well are also varying. So it's not just DOS attacks anymore. We're now seeing attacks at the application layer. SQL injection attacks, cross-site scripting types of attacks are all becoming more popular as well. And these are also areas where we can actually provide a benefit as well. So with Akamai, what we can do is, if you don't have Akamai in the picture, these types of attacks, DDoS attacks or application level attacks, go direct to your infrastructure. When you put Akamai into place, what we're able to do is essentially front end that, right? So now, instead of all that traffic reaching your infrastructure, it now gets absorbed through Akamai's distributed environment. But what we can also do is provide a web application firewall type of capabilities from our platform or servers, right? And ensure that bad traffic or requests from bad end users never reaches your infrastructure. So things like SQL injection attacks or for that, like that, just essentially are caught by our edge servers. And what we can also do is, in the event of a widespread attack, these attackers can take down one of our regions, but will simply, fail over to secondary locations. So the end users who are your good end users pass through and they're able to receive the content. So this is just an example of some of the attacks that we've seen. This was back in 2009 of the bot attack that originated out of Korea that some of the US government agencies saw. You can see here a range anywhere from 6x their normal traffic patterns up to 600 times their traffic patterns. And all of these were protected and they continued to be up and running because they were on our platform. But you could see the largest one there was handling 124 gigabits per second. So again, this is just an example of the types of attacks and how they're increasing. So now we'll move over to what we can do for SaaS providers and what we can do for you who are leveraging SaaS providers. So these are applications that are completely out of your control. And if end users have problems, it really is hard to address. So what we did was we partnered with Riverbed to essentially address this challenge specifically. And we took a look at the top 3 SaaS providers, Office 365, Salesforce, and Google Apps. And what we did was we worked with Riverbed to, 1, incorporate Steelhead, which already exists in a lot of remote offices and a lot of branch offices, incorporate those onto the Akamai platform. So embed them onto our edge servers and also distribute them close to these SaaS providers. Then what we also did was we embedded Akamai's capabilities within Riverbed's technology, within Steelhead's servers. So now Akamai is now distributed within those remote offices, within those branch offices as well. And the combined benefit is dramatic. What you're getting is the Steelhead deduplication technology now combined with Akamai's optimizations and connection optimizations, right, to optimize the experience of your end users from the remote offices or your central offices to those SaaS environments. And this is just an example of some of the results that we're seeing from testing out this technology. This is an example of a 9 megabyte file getting downloaded from Office 365. In one example, you have without the Akamai Riverbed solution, and in the second one, you have with the Akamai Riverbed solution. And you can see just the download time is dramatically different. And that has to do with the deduplication technology and the routing mechanism that we have in place. The same thing is true on the upload side. Now, because it's a symmetrical deduplication technology, what we're able to do is not only provide benefit on the download, but also on the upload side of that content. And that's where Riverbed's technology is also coming in and providing a dramatic lift. Okay, and with that, that is my last slide. And I want to thank everybody for their time. If you have questions, I'll be up here afterwards. You can email me as well. Email is ballabio@akamai.com, or you can tweet me at Ballabio. And one last thing, we actually have an application that you can download from iTunes to get a real-time view of what Akamai is serving just on your iPhone or on your iPad. And it's a really neat view to kind of see what's happening out there in the world of the internet. Thank you.